My friend Dr. Bisher wanted to come say hello. So what we have, what I was telling you is that in this model we have half of it, the podocytes, these Bowman's capsule cells have been removed to show you the blood vessels underneath. But all these blood vessels are just totally wrapped and invested in these cells, which make up what we call a visceral layer of Bowman's capsule. These, similar to the blood-brain barrier, the astrocytes in the blood-brain barrier, which totally wrap around those blood vessels in the brain, these totally wrap around, but there's slits and openings that fluid and different substances can pass through into Bowman's capsule. And those things are pushed out, those substances, whether it's fluid or ions, electrolytes, etc., sometimes small amounts of protein, whatever, are collected up into this space, which drains out of Bowman's capsule and enters the nephron. This tube right here leads to the proximal convoluted tubule. Okay, so this model definitely on a lab exam. This model definitely on a lab exam. Definitely. Anything on that list, I'll put a sticker on it and ask you to identify it. Okay, so make sure you guys are comfortable with that. Let's look at the dry erase board here. Something that you should be able to do on a piece of scratch paper or a dry erase board or a poster board or whatever you have and whatever you like. You have to be able to recreate this, these structures that I'm about to do. So how I draw it is I draw an afferent arteriole coming in. Man, it's really hard to see this. Gosh. Hopefully this won't be too painful for you. I know it's difficult to see. But I draw an afferent arteriole coming in to the glomerulus, which draws this winding thing, and then I draw efferent arteriole leaving. Okay. Then I put in a crescent-shaped funnel to represent Bowman's capsule. This crescent shape represents Bowman's capsule that leads into a proximal convoluted tubule, a descending nephron loop limb, an ascending limb of a nephron loop, distal convoluted tubule, and a collecting duct. Okay. And the things on this diagram that you could label are afferent arteriole, glomerulus, efferent arteriole, Bowman's capsule, proximal convoluted tubule, descending limb of the nephron loop, ascending limb of the nephron loop, distal convoluted tubule, collecting duct. It moves in that order, it moves in that direction. These are the named structures of the nephron that I have there on our list. Okay, these are hollow tubes that urine passes through, and as urine passes through, it's subject to addition and subtraction of water and electrolytes and all different types of materials, and the epithelial cells of the nephron tubules govern and dictate how that urine is adjusted and fine-tuned, and then the final product, when the nephron's all done with it, is excreted and urinated out. This efferent arteriole becomes this peritubular capillary network. And just like I told you before, every capillary bed in the body has an arterial side with big arteries branching into smaller and smaller and smaller arterial capillaries, continuous with these small branches that blend into larger and larger and larger veins bound for the IVC and the right side of the heart. So these peritubular capillaries become ultimately larger and larger veins, interlobular veins, arcuate veins, interlobar veins, etc., etc., etc. Remember the arterial branches. Some people say Ralph sits in an igloo and grunts effortlessly. Ralph, renal artery, segmental artery, interlobar, arcuate, interlobular, afferent arterial, glomerulus, efferent arterial, peritubular capillaries, and then the veins and mirror image. Okay, minus segmental. Other important things about the urinary system: those bilateral right and left ureters come down in the retro P and drain urine into the bladder. Bladder, muscular sac, detrusor muscle, internal external urethral sphincters. The trigone is the triangular shaped region that's formed when you connect the dots. The dots are the two ureteral openings and the opening into the urethra. That's the trigone. Internal urethral sphincter is smooth muscle, involuntary. External urethral sphincter is skeletal muscle, voluntary. Urethra. That's it. I can't think of anything else. I wouldn't say that this is definitely exhaustive, but I think I've mentioned everything pretty much that's important.